River processes. A process is a method that results in a change in a physical object. Rivers do three main processes. Erosion, where rocks are worn away and the land changes shape. Transportation, where eroded material is carried by the river downstream. Deposition, where transported material is dropped when the river loses energy, such as when it enters the sea. Courses of a river. Upper, middle and low course. The upper course. Vertical erosion is the key process here. The river does not have enough energy to erode laterally. Interlocking spurs are like a zip. The middle course. In the middle course, rivers have more power and can laterally erode. The river channel is deeper, meaning less resistance, so the water travels faster. Meander, an erosional and depositional landform. A meander is a bend in the river found in the middle course. The natural features as a result of deposition and erosion. Water in a river naturally flows in a corkscrew pattern known as a helical flow. The helical flow sends the water's energy to the sides of the river, lateral erosion. The current is fastest on the outside of the river because it is deeper, and therefore there is less friction to slow the water down. Here it erodes the river bank. On the inside edge of the river, the water flows more slowly, because the channel is deeper, and therefore there is more friction. The eroded material is deposited on the inside of the bend, known as a point bar. This creates the meander. Over time the river can erode so much that two meanders eventually join to create a new channel and an oxbow lake. Oxbow lake. An oxbow lake is the result of two meanders eroding and eventually joining to create a new channel. The river usually breaks to create the new channel during a flood. Deposition eventually cuts off the meander, forming an oxbow lake. The lower course. In the lower course, the river has a high volume and a large discharge. The river channel is now deep and wide and the landscape around it is flat. However, as a river reaches the end of its journey, energy levels are low and deposition takes place. Floodplain, depositional landform. The floodplain is the wide valley floor on either side of the river which occasionally get flooded. When a river floods onto the floodplain, the water slows down and deposits the eroded material that it has been transporting. Meanders migrate across the floodplain, making it wider. The deposition that happens on the slip-off slopes of meanders also builds up the floodplain. Estuary. This is the area of transition between the river and the coast. They are affected by river and coastal processes. During a raised tide, the river will not discharge into the sea. This leads to the river's velocity falling and deposition occurring. This can form extensive mudflats and over time salt marshes. Levee. Levees are the built-up sides of the river. They can be natural formed through deposition or man-made. Delta, depositional landform. When rivers meet the sea or a lake, they are forced to slow down. This causes them to deposit the material they are carrying. If the sea does not wash this material away, it builds up and the channel get blocked. This forces the river to split into lots of small rivers called distributaries. Eventually, when enough material builds up in a low-lying area of land, a delta is formed. Discharge. Discharge is the amount of water flowing through a river at any one time. It is measured in cumecs and is calculated using discharge, m3, sec, equals cross-sectional area, m2, x velocity, m, sec. Flooding. A flood occurs whenever a river overflows its banks, exceeds its bankful discharge. However, a flood becomes a problem when the water rises to a level where it threatens property and/or life. Rivers usually flood due to a range of physical factors. These physical factors can be divided into climatic factors and drainage basin characteristics. Human intervention can also make flooding worse. Urbanization, increased impermeable surface equals increased runoff into rivers and streams. Deforestation, reduced interception equals increased runoff and erosion of the land. Flood management. Hard engineering. Hard engineering options tend to be expensive, short-term options. They may also have a high impact on the landscape or environment and be unsustainable. Dams and reservoirs. Widely used around the world. Main functions: prevent floods, hydroelectric power, irrigation, food supply, recreation. They can control water flow and be very effective during heavy rain. However, they often flood large areas of land, destroying farming areas and meaning people have to move home. Channel straightening. River can be engineered to be straight, usually achieved by cutting through meanders. It speeds up the flow of the water, but this can result to greater flooding downstream. The streams are often lined with concrete to stop the channels collapsing. They can be damaging to the environment, but they prevent flooding in the middle course. Embankments. This is raising the river banks at the sides of the river. It stops flooding and it is often used in towns and cities. Concrete blocks are often used to raise the level. Sometimes they achieve embankments by dredging the river channel. This is more sustainable. Flood relief channel. Man-made channel designed to bypass urban areas. During times of high flow, greater flow can be encouraged through opening gates. Reduces flooding threat. Soft engineering. Soft engineering options are often less expensive than hard engineering options. They are usually more long-term and sustainable, with less impact on the environment. Afforestation. Planting trees to stop the water's flow and slow down movement of water to the river channel. The trees also soak up water. This is sustainable and cheap but can take a long time to take effect. River restoration. When a river has been artificially changed, it may be of benefit to change it back to its original state. This reduces the likelihood of a major flood downstream. Wetlands and flood storage areas. Wetland environments are very effective for storing water. This reduces the risk of flood downstream. Floodplain zoning. This restricts certain land use on the floodplains. Areas prone to flooding can be kept clear of houses and industry. Instead, the areas are used for low-value things such as pastoral farming and playing field. This can be very difficult to implement. Preparing for the flood. We can try to predict floods using Met Office data. People can prepare their homes for the flood, for example using sandbags. The local authorities can prepare areas. People can leave if necessary.